Hey, Homestead Prepper. Today we're going to try and hook up an electrical sub panel. And before we get started, I need to tell you guys that you need to work at your own risk. And if you do attempt to do any electrical work, you do it under the direct supervision of a licensed electrical contractor. Electrical work is very hazardous, and it can be even deadly if you don't know what you're doing. And even if you know what you're doing, you can still get electrocuted like I did. And I guess I was dead for a short time, but it's not a joke, and don't be cocky around it, and get help. Also, your codes are going to vary from area to area. I mean, even here in my area, in my own county, you can do something in one part of the county and the inspector will say that's great, and then he goes on vacation, and in that same part of the county another inspector will come out there and he won't like what you did, or he'll want some modification to it or adjustment. So contact the authority having jurisdiction, which would be your local building department or your electrical inspector. And that way you make sure you're doing everything right. Now, what I'm going to show you, this video is for entertainment and information purposes only. So this is just an overview of electrical, how we do it in this area. Anyone wanting to do some electrical work, I wouldn't go by this video. Like I said, I'd get an electrical engineer to draw up something, consult your building department, get a permit, and have it properly inspected. Now, I know there's going to be some people out there that say, well, I don't like that work at my own risk, and you're really going overboard on this contacting professionals and everything. Well, you know what, guys, every time I make a video and I put a disclaimer in there, somebody comes up and they say they don't like that. So here's what I'm going to say to everybody who doesn't like my disclaimers. Come to Florida, get your own state certified electrical contracting license, put some videos on YouTube, and put a little statement there that you're open to litigation. Okay, so all right, well, let's get started with the video. This is the panel I'm using today. It's 8 or 16 circuits, which means there's a maximum of 16 circuits that I can put in there if I use the wafer breakers. I'm using an outdoor panel because I'm putting it outdoors. Now, if you're working a sub panel indoors, then you want to get an indoor rated sub panel. Now, you can use an outdoor panel indoors, but you can't use an indoor panel outdoors. I mean, just, a lot of electrical is just common sense. Okay, well, let's get this thing opened up. I've already got it ready. You take the cover off. This can come out. And if you look in there, I've already mounted the ground kit. Mounted that right there, and this is the neutral bar, so this is the grounded conductor, this is the grounding conductor, and your panel will probably come with a bond screw. And if this is a main panel, right after the meter, first means of disconnect after the meter, then you would put this in and your grounds and neutrals would go in here, unless the authority having jurisdiction wants a separate bar mounted over here and then a main bonding jumper, and then you would put the grounds on one side and then the neutrals on the other side, even though they're both connected. So anyway, that's the way it's done in my area. We've got this up here, being this is a rain type panel, put a hub up there. It comes with a block off plate to keep the water out, so let's just go ahead and put that on. Drop one of the screws. I don't know. Anyway, it's not rocket science. But they make weather type hubs for this right here. But we're not coming out of the top of the panel for anything. Okay, so we got that ready. Anyway, this panel is ready to get hooked up. So all I need to do is screw it to what I'm going to put it on. Alright, if you can see, I've got the panel mounted and I've got it dead level. I put one screw right there, and that's just to to hold it up there. So let's put another screw in it. See if it'll go. Get another screw handy here. I'm using self-tapping screws because I'm screwing into metal. Now it shifted a little bit. That's alright, we're still level. We can see that. Still in the ballpark, so I just put a couple more screws in here. Put one like right here. And I think if we put one more in, I think we'll be doing well. And there we go. This panel is not coming down. Okay, we got that all nice and level. We got our PVC that comes down. I've got this ditch here. I've got another video on how to put PVC together. I've got the pipe 18 inches. Well, the ditch is 18 inches to the top of the pipe. That's what's code in this area. Your jurisdiction might be different. You might have to be 24 inches. I don't know. Might be able to be less. Who knows? I've got it running all the way over here. That's the heat gun I used to this panel right here. So, alright, well let me get a fish tape out, and I'll have to get a wire measurement, and we'll get this wire pulled in. I still need to strap that pipe right there. I've got the ditch covered up, and I want to make a note that it is against code to throw debris back in the ditch when you cover it up. So like that root, stick, those rocks, you're not supposed to put that back in there. Just nice, clean, fill dirt. So I got it all nice and covered, and if anybody's interested, it took me about 2 hours to dig it, and it took about a half hour to cover it up. So anyway, that's where we're going. I'm going to take that fish tape down there in the lower right part of the screen, and we're going to run that through there. Okay, this is my fish tape. Some people use string, and they, put a mouse in there and they suck it through with a shop vac. I'm going to be using this to pull. So if you notice the head on this is not just a piece of wire that's cut off here, because when you try and push it over to the other panel, it'll get stuck. It'll hit on stuff, and it'll cause you a lot of grief. So what I do is I bend this little thing around like this, and then to keep it from snagging, you put a little electrical tape right here. This is 3M brand. I mean, you can use the Harbor Freight stuff, whatever you want, but this is what I use. So we're just going to wrap this around here like this. Put this on, and if you go to pull it back out for whatever reason, it won't snag and catch on anything. So the fish tape, you just pull like that, and this just unwinds it. So you put a little out. Now this is the live. This is my main panel right here. So I'm going to be pulling from this. My helper is going to be on the other end. Yeah, I can't state enough how dangerous electrical is, and I can say that because I've been electrocuted before. So, okay, so you just take this, and this is the pipe that we're doing. We're just going to stick that in there, and you pull this, and you just stick it in like that, and it just goes right in. So we'll get that down there, and it'll go on the other side. A special note, like I said, this is the live main panel that has power in it right now. If you were to push from the sub panel over to here, and this were to hit one of these lugs or bus bars, you would get electrocuted. So like I said, guys, work with a pro and take all your safety precautions very seriously, and don't be cocky like I did, and that's how I ended up getting electrocuted. So let me put that down. I'm trying to. What you do is you have somebody stand on the other end, and then you could push out, 40 feet of this if you're not careful. So always have a helper. Just push this down here. And like I said, don't, you have to be wary of what you're doing here. Now you can call the power company and pull the meter if you need to be extra safe. Probably be the smart thing to do. Alright, let me get that pulled in over there. Alright, let's... Okay, we got the fish tape here. All we need to do is make up the head and get the wires pulled in. Okay, now y'all pay attention to what I'm doing here. I got my fish tape and I have my wire stripped, and what I'm going to do is I'm going to put it just like this, and then I'm going to take this in and fold that over like that. Okay, now here's where the trade secret comes in. This is my neutral, number 6. So we're going to take a dull knife and we're going to skin it. And then what we're going to do is we're going to take, say, maybe couple strands out of one side, and then we're going to take a couple strands out of the other side. You can see what I'm doing here. And then what we're going to do is we're going to cut. We're going to cut this center part out right here, and then we're going to do the same thing to this, only what we're going to do is we're going to stagger it. I'm not going to put it all right here. We don't want to make the head so big. We come down a little bit, and we bring this one like this, and then we bring this one like that, and then the next wire we'll do the same thing. We'll put it here, and then we'll put the next one down here, and then we'll tape it all up. And what that does is that keeps the head from being massive, because if the head is too big, it won't go down in the pipe, or it'll be a really tough pull. So that's how I do it. And some people, well, let me get this made up here. Okay, I got the head made up. You can see that's nice and small. I wrapped it, actually double wrapped it with tape. Now this is wire pulling lubricant, and this is yellow, number 77. And they have some blue stuff, and it has a bunch of colorful names in the trade, but this is yellow 77. So what we're going to do is we're going to put this on here and get this lubricated. You want it nice and go all the way down the wire, and we want to put some excuse me, down there like that. And you just lubricate this, and it's going to make the wire pull just so much easier. So, and what I usually do is, as the person's feeding it, you shoot a little bit of it down there. It doesn't affect the wire. Long time ago, I worked with a guy, and he used motor oil as a lubricant, because he said lubrication, but he said that the wires were oil and gasoline resistant. Now, I don't recommend you do that, okay? But this is the proper way to do it. Some people use dishwashing soap. That'll work, but this right here is the best. Okay, here we go. You guys can use gloves, or if you're tough enough, you can use your bare hands. All right.
Okay, I'm ready.
Well, there we go. What you want to do is pull this to the top of the panel. You're going to cut that portion off right there with the tape and clean this off, and that should give us plenty. Alright, it's there. Okay, that's the head right there. What we're going to do is just cut this off. And I've got a rag and I'm going to wipe that stuff off of there, the soap. What you have to be careful for is if you phase the wires, you don't cut the phase tape off and then you have to ohm it out. So, get that green wire over there. Just take this little shop towel here and just clean the wire off. Get that clean. Okay, that's cleaned off. All we got to do is make space in there for a 2-pole breaker. Okay, we got that cleaned up, and you can look and you can see that that's looped. That was just one wire. That was not 2 pieces of wire, and all I did was hook up the ends and pull it through. And if you look at this, it'll say what size wire it is. This is going to be a 60 amp circuit, so this is actually good for 75 amps. So I could put a 70 amp breaker on here. Of course I'd have to increase my ground size to a number 8. This is a number 10, but I'm just doing 60. That's all I particularly need. And if I overrate the wires a little bit, then that's good. And we have a continuous white number 6. You can't derate the neutral on this type of circuit here. So alright, well, what we're going to do is just cut this off. And what I'm going to do is cut it a little extra. So what most electricians do is you pull the wire up to the top of the panel, like right there, and that's where you cut it off. I usually do that, and then just give a little extra. Because it's better to have a little extra than not enough. So let's cut that one off. There we go. Okay, and according to our National Electrical Code book, we have to ground our subpanels with grounding electrodes. Some places may say 1 electrode, some places say 2. This particular area says you got to have 2 grounding electrodes. These are 5/8 by 8 feet long, galvanized. You know, your local jurisdiction might say you got to have copper, but around here galvanized is fine. And the ground around here is so soft you can take your hand, well, I usually use 2 hands, and you can just about beat this thing in the ground until it hits the hard pan, or there's some red clay down there sometimes. If you go over to like Pinellas County, you get up around the saltwater, you'll have to beat that in with a hammer. This one is sticking a little high out of the ground. I remember the old days we'd get a ladder out and our 16-ounce hammer and drive that thing all the way in the ground. But I'm going to take both hands. I'm going to do the same thing. This is probably about as far as this one's going to go, and I'll have to beat it. Let me just show you a trick that I use, because what happens is when you beat it with a sledgehammer, this will mushroom out and you won't be able to get the ground clamp over it. So let me show you what I'm going to do. Okay, as I stated before, when you beat this with a hammer, sometimes this head will mushroom out so big you can't get the connector over it. So what I do is go ahead and put the connector on, tighten it up, and then what I'll do is I'll take some black tape, because a couple hits with a hammer, that thing will loosen up and it'll come off of there and it'll slide down, and you'll make a hole down there and you won't be able to get your connector out sometimes. So just go ahead and tape it up. Like I said, I guess there's other ways to do it, but it sure beats the alternative of beating this thing in the ground and then having to get a hacksaw and cut that off just so you can put this on there. The inspectors around here like it about 6 inches out of the ground. Some other places around here, they like to have it beaten below the grade. So alright, there we go. That's ground rod number 2. Okay, something else I want to show you guys is the ground rods have to be a minimum of 6 feet apart. And if we look here, we're almost 7. So if you put it any closer than 6, that is against code. So I used to work for a guy, he was so cheap, what he would do is he would put them exactly 6 feet apart, and then he would bend the tops over so he would use less ground wire. So, but I mean, I don't recommend you do that. But okay, well, let's get the rest of this hooked up here. Okay, according to Article 250.66, our grounding electrode conductor, when we have a service wire which is number 2 copper or smaller, which we're using number 6s, that the right copper wire to use for the grounding electrode conductor is going to be number 8 solid. So this is what I have, is some number 8 solid. We're going to go from that ground rod to that ground rod. And we also need to ground the shipping container too, because it's metal. Okay, you want to dig a little ditch right there, and you want to bury the wire. You want to protect it. I guess I need to go a little bit deeper than that, but I'm just showing you what you do. And then the wire, like I said, is going to run up right here into this panel. So let me get that dug out a little bit more and get that run. Okay, we're just going to feed this ground wire through the pipe like that. And there it is. All we need to do is just put it in there. I need to get some glue right here and glue this thing in there. Alright, get that wire and put it right there in that connector. Let's get a little glue. Okay, we got the wire in here. You notice there's no insulator on here. I guess, you know, what are we afraid it's going to get grounded or whatever? But anyway, it's PVC, and you know, your inspector might say no, he wants an insulator on there. I have no idea. But I'm not going to put one on here because it's usually not required in my area. You can take the wire and bend it like that, and we're going to go in this ground bar and try and be as neat as possible. And I think if we take our pliers and bend this like that, I think we can go right there. Take our screwdriver. Put that in there, and you want a little bit to come out on the other side. Let me show you that. And we're going to tighten it down. Okay, I just wanted to show you up close. When you run the ground wire, it comes up, it goes through the back here. Don't put the ground wire next to the nut because you'll cut it in half, and that's not the proper way to do it. It's got to go along the back here. We're just about ready to do the smoke test here. So if you notice, I've got a couple blanks in here, and there's an open right here, and I've got some of these filler plates. So we're going to take one of these, take that out, and we'll just go ahead and just put it right in there. Snaps right in, and there. Now it's a lot safer. I've had to relabel the panel. I don't know, I guess I need to get some gray paint or something, and it wouldn't rub off. You have to mark this permanent. You can use these little stickers right here, but I like to write it in marker. So alright, well, let's give it the test. We'll see if anything flames up. Alright, well, that's a good sign. It is always a good idea to check your work. I don't care how perfect you did the job, how well you think everything went, you need to pull your meter out and you need to check your voltages when you're finishing up on a job. So let's turn this on here to alternating current, because that's what I have available to me right now, 60 Hertz. And we're going to do a little check right here. Let's do a check and see if we got 120 coming in. So we'll go across here, and it says we got 247.5. Let's go from a hot to the ground dead conductor, our neutral, 123.7. Let's go to the other phase over here, 123.8. Let's go from here to the grounding conductor, 123.7. Let's go to the other phase, 123.7. Okay, and I always like to go across the grounding conductor and the grounded conductor, and I've got 0. If you go across your ground and your neutral and you've got like 120 volts, you got some big problems. You need to work that out. Guys, the reason you need to check the voltages, and I'm so adamant about that, is because years ago I worked at a company and there was like 11 service techs there, and Kinko Copier called up and they had a new machine they wanted hooked up. It was a 120 volt 20 amp dedicated line it required. One of the guys went out there and they got it all hooked up and they plugged it in and they left, and later that day Kinko's called and said their copy machine wasn't working. Well, someone else went out there, and what had happened is this is a single phase panel. You've got 2 hots here. Well, this was a 3-phase panel at Kinko's. It had A phase, B phase, and C phase. So if you can just pretend along with me here that that's A phase, that's B phase, and that's C. The guy had put the breaker on the B phase, and on that particular type of transformer, a delta, it's 120, 208, 120, and he snapped it on the the 208 volt line, and there was 208 volts going to that copy machine, and it burned it up. So always check your work. I can't emphasize that enough. Okay, well, I think we're going to call this a wrap. Homestead Prepper out.